Good morning, everybody. Welcome to another installment of the Inventor demonstrations that we're going through at the moment. Hope you're all well. I see quite a few of you have joined. I'm sure more will be joining over the next coming minutes. But essentially for today, what we're going to be looking at is the Inventor Design Accelerators. Quick introduction to that is obviously when we're designing inside of Inventor. Up until now in the series, we've obviously had a look at designing individual parts, and then in the designing inside of the assembly environment. What the design accelerators will do is they'll take certain standard parts, whether they be bolted connections, whether they be frame generation and bearings and gears, and use the content center that's built inside of Inventor to be able to start to configure and help you create assemblies a little bit quicker. Again, building on the backbone of the Inventor Content Center. Today we're just going to have a look at a few of those. We're just going to go through a quick introduction of the design accelerators and just see where we can get some great benefits from using that inside of Inventor. Sorry, I also haven't introduced myself. My name is Cameron McKenzie. I'm an applications engineer here at Man & Machine, and I'll be running through the series as a whole. So if you have caught any of the previous episodes, welcome back. If this is your first time, welcome to this episode. Feel free to have a look at some of our previous episodes as well. They are on our YouTube channel, as will this one be in the next day or so, once this webinar itself has finished. Apologies, I've got a bit of a tickle in my throat, so my voice doesn't sound quite the same as usual, but we'll be able to get through this and we should be fine from there. So without any further ado, I'm just going to head straight into Inventor. So to get it back, open up over here quickly. And I'll just give you a quick overview essentially of how Content Center itself works. A lot of people aren't aware that inside of Inventor, inside of your default Inventor installation, there is a content center that's available to you. And the way we can access that is inside of our assembly environment. So if I just open up a new assembly, if I'm on my home screen and I start a new assembly, or if I am inside of an assembly, I can actually access that content center. So if I select assembly, part file or as an assembly file to open up from the home screen. In my component panel, in my assemble tab, I've got the ability to place down items. So I can either place down locally or from a local file, or I can place from Content Center using the little place drop down over here. I've got access then to place from Content Center. So if I select place from Content Center, essentially this takes me through to an entire database that's saved. Sorry, this opened up on my other screen. That's saved onto your local database. Whether you have your Content Center saved locally on your machine, you've also got the ability to save it onto Vault if you are making use of the Vault library and storage within your system. So either way, you've got the availability of this Content Center, and this will have various standard parts that we can pick from, whether they be cable and harness parts, whether it be fasteners, any specific features. We've got arc slots, blocks, C-channels, cones. We've got molds that we can pick from, other parts, sheet metal parts, structural shapes. And this is essentially the backbone of what Inventor allows us to use inside of the design accelerators. So it's a whole lot of standard parts with varying sizes, varying standards. If I just have a look at some of the structural shapes over here, if I just pick a square or rectangular tube, you can see I've got various standards for the sizes and shapes essentially of these tubes. And it's the same throughout all of the others, whether you're looking for round bars, whether you're looking for I-beams, whether you're looking for sheet metal. There's some sheet metal nuts and other features and parts that you can essentially come in and add to that, as well as a whole library of fasteners. So whether you're looking for bolts, nuts, pins, rivets, washers, you can come in and start to choose those from a wide range inside of the content center. You can also then filter those down based on the different standards. So whether you're working to a specific standard, you could then come in and filter down your library to that. Say, for example, we wanted only ISO standard parts. It'll then give us the list of ISO standard socket heads or set screws or hex heads. So you can see we can quite easily filter those down and start to use those in an assembly environment. And essentially what the design accelerators then start to do is they accelerate your design process. So they take any assembly that you've created, whether you have existing parts inside of it or whether you don't have any existing parts, they all will differ based on the geometry that they require essentially to actually create your parts. So the design accelerators are under the design tab inside of Inventor, and you can see we've got various ones that we can choose from. So the first and probably the most popular one is the bolted connection, and that essentially creates a bolted connection between two parts. Whether you've got the holes there or not, it will need a circular reference, and that's the first one we're going to take a quick look through. So I'm just going to open up this file over here that I've named pipe assembly. You will need to be inside of a saved file in order to a saved assembly file to be able to start the process off. So I have saved this file as pipe assembly, and I'll show you just now when I open up a different one, what message comes up and how we can deal with that. So the first thing I want to do for this pipe assembly is obviously to actually create the assembly itself. So I've made a few parts that I just want to add in. So I'm just going to, instead of placing from contents in, I'm just going to use the regular place. And I'm going to pick up from, I have a bolted connection assembly. I'm going to create from a straight pipe, just place this in. I'm now going to ground this in the 3-dimensional space so that it doesn't move around. So I'm just going to right click on the part in the model browser on the left-hand side and just select grounded so that this part doesn't move around anymore. You can see I've already created holes in there so I can know where the bolts need to line up to. I'm then going to place down 2 elbows quickly, one on either side of the straight pipe. So I'm going to go place, I'm going to select the elbow, open that up and place one part there and another one there. Then we're going to right click, select OK to finish that off. And I've now got 3 parts inside of my assembly. I then want to create a relationship between these. If you want to know how to do that, we did do a video a few weeks back showing how we can create relationships between items. Feel free to have a look at that as to how we do that. I'm just going to quickly place 2 joints between there just to make sure that those are lined up. And I want a rotational one just so that there's some movement. And I'm going to do the same between the other 2 sides. And just flip that around and apply. There we go. Cool. So we've got these 3 parts together. Straight part is broken. It's rounded. So just place the grounded restriction on there again, and you can see our parts can rotate around. So that's all good and well. Now, essentially, all I need to do is decide how I want these connected. And obviously, in this case, we want these to have a bolted connection between them. So I want to use those holes that are currently on the part itself and create a bolted connection between the 3 parts, essentially. And to do so, I can go over to the Design tab, select Bolted Connection, and you should see a bolted connection. Sorry, again on my other screen. This is what happens when I practice on the one screen and live on the other one, but that's okay. Essentially, we've got this bolted connection dialog box that pops up. What this essentially wants to know is whether we're going, what type of hole are we wanting to create, or what type of connection are we wanting to create? Are we wanting to create a connection that goes through all, so it goes through the entire selection, or are we wanting one that has a blind connection type, so it only goes through to a certain depth? In this case, I'm going to choose a through all. And then it wants to know what type of placement am I wanting to use? Am I wanting to use a concentric placement? Am I wanting to place my bolts or my connection point at a specific point? or do I want to go by a hole? So in this case, I've essentially got a few of the options because the geometry is already there. I could choose either concentric, I could choose by hole, or I could choose on a specific point. For this one, I'll just choose concentric quickly. And what you'll notice with concentric is it then just requires, first of all, a start plane. So it wants to know where we want to start the bolt from. So if I just choose that plane over there, the next thing it wants to know is a circular reference. So with it being concentric, it wants to know the exact center point of the hole, of the bolt itself. And for that, with the concentric one, I can choose any bit of circular geometry, whether it be an arc, whether it be a hole, whether it just be a circle or a point on a sketch, essentially, that I can use. So I can choose any circular reference, essentially, for that, and it will automatically pick up the center point of that circular reference as my center point of my hole. If I change that instead to by hole, it would then want to know where the existing hole is that I want to apply this to, and I can come in and pick that one. It's picking up the original one from, because all of the other holes are essentially a pattern of the one. So if I select that one, that'll be the original one that it's picking up from there. Otherwise, I can choose on point, and I could then essentially just pick a point. I don't have any points on the sketch, so it's not going to pick that one up. And then other one would be just a linear one where I can choose a linear edge. So you can choose two edges and you can give it a dimension essentially from an edge. But for this one, I'm just going to choose by hole, and I'm going to pick that hole just to make sure that that's the one that it's assigned to. And you can now start to see it's already giving me a bit of a preview as to how it's going to be creating this. So it's giving me this dark blue cylinder as a bit of a preview, and it's then asking me where I want to terminate this this bolted connection. So it's asked me where I want to start it from, and now it's asking me where I want to terminate it, and obviously where the existing hole is that we're going to add to this. So I'm just going to choose this back face over here, and you'll then start to see that it's now picking up, okay, if we're wanting to add this in at this particular angle, I seem to have one hole modeled into the original side. That's a bit odd. But it's going to now realize that because that's a solid face, it's a solid surface, it needs to then cut the hole. So it's automatically picking up the size of the existing hole and saying, we need to now drill a hole through this to be able to create that. So it's automatically picking that up for us. What we can then do is we can start to build up this bolted connection as well. So we can come in and say we want to add a fastener. And by selecting add fastener, this will now load the content center where we looked at earlier and look for the relative sized bolts that we can start to attach to this. So I can come through and look through my entire library of bolts and choose a bolt that I want to add to this. If I wanted to filter this down, I could use my filter over here as to which standard I'm wanting to use. So if I wanted to use an ISO standard bolt, I could pick that from the list. I could choose whether I want bolts, whether I want hex head bolts, socket head bolts, and start to filter those down even further. So if I choose a hex head bolt, you can see these are the ones that are then available to me. So I'm just going to pick the ISO 4114. And you can see now it gives me the preview of it. And again, it's picked up the size, the diameter of the hole, and automatically applied a bolt for me. So it's placed down an M30, and it's given me the ability to place that straight in. If I wanted to now, I could also start to add a washer. So if I add a fastener over here, you'll see it already knows, obviously, we're not wanting to add another fastener. We're likely wanting to add a washer. So I could come in, pick a washer that I want to add to it, and it'll give me the preview of that. So that's on the start plane. We then obviously want to add a connection or a fastener on the termination plane. So I can come to the side over here. So it's showing the, at the top of the list, it's showing the start plane. In the middle, it's showing the hole. And at the bottom, it's going to show the termination plane. So I can select to add a fastener here. It wants to know if I want to add a washer because I added a washer on the other side. And for the sake of this one, I'm just going to choose another washer to add to the bottom. You can see again, it gives me the preview. I can then say I want to add another fastener, and this time it will add a nut that I can choose from. I could still add another washer if I wanted to. In this case, I just want to add one more, which will just be the nut. And I can choose from the list over here again. So I'm just going to choose another one, and it gives me the preview there. If for some reason I wanted to ensure that there was just a little bit more length to my initial bolt, I could come in and use my length option down here. It's giving me the two arrows here where I can actually adjust the size or the length of my bolt. So if I wanted a bit more room, just for future expansion, maybe you want to add a gasket or something in, or some other bit of material in the middle, or just have some room to play with. You can always come in and add length to it, and you can see how the value is now changing. The designation of the bolt itself is changing inside of our list over there. We could also at any point override the diameter of our bolt, or at least of the thread over there. So if we wanted to, we could come in and choose a different size in there at any point as well. Once we're happy with that, we can then just hit apply, and it will then create that for us as a bolted connection. So you can see down here on the within our model browser, we've now got the bolted connection. If I just close this off quickly, we've got a bolted connection assembly, and essentially we've got all of the individual content center parts listed in there. So we've got the washer, we've got the bolt, we've got the washer on the other side, and we've got the nut on the other side as well. And they will all have their own relationships as well. So they've got an insert constraint on there. We've got a mate constraint with some of them, and some other insert constraints or joints essentially that drive the connection of all of those. If we then wanted to repeat this across the entire part, we could then just create a pattern essentially of that particular object, or of all of those objects. So if I wanted to, I could come in and select all 4 of those items and say in the Assemble tab that I want to create a pattern. Again, sorry, on the other screen. And I want this pattern to be circular. I want the reference to be the center of this hole or of this pipe, and it will then create the pattern for me from there. It's now saying we want 90 degrees apart. If I drop this to 60 degrees apart, and I want 6 instances of that, you can see it then repeats those across with all of their joints, essentially from there. As soon as I hit OK, it will now create a pattern of those items and set them all as individual elements. So we've gone from just 3 individual parts to quickly going into the bolted connection, making the connection itself, and then being able to adjust it from there. One thing we can also do is we can, in the bolted connections themselves, so if I just go and quickly go back into the bolted connection, once we've created a setup essentially that we want to be able to reuse, we can always save a template of those. So if I quickly go through the same process again, just on the other side, I'm just going to choose the start plane, choose the hole, if I can find it. Where's the one that it needs? It's not picking that one, so I'm just going to go by concentric quickly and choose that one. That'll be fine. And then termination point on the opposite side. Thank you. If I add a fastener, add a washer, add a washer, add a nut, I can essentially save this as a template file. So if I save this quickly over here, it'll save it to a bolted connection folder, or whichever folder you really want to save it to in your local database. You can give this a name, whatever you want to call this, standard bolted connection. Or if you wanted to give it a project name or anything like that, you could just save it in there. So that's now saved. If I cancel this out quickly and go through the same process, say, for example, we're wanting to place another bolted connection on this side, it's automatically added those other holes into the original part, and that's what's happening in there. If I come in, bolted connection, select the start plane, select an existing hole, I could always come in here and import a template. So I can select import template. I can find that one, I believe it was Design Accelerator, bolted connection, standard bolted connection, open that up, and it will have loaded that configuration for us. So if you ever had a specific standard configuration that you wanted to use quite frequently, you could always save that out as a template as well. Awesome. So that's a bolted connection. Sorry, I've taken a bit longer on that one than I was expecting to, but I'm hoping that's been beneficial for you. The other one I want to show you quickly is the ability we have to create bearings or add bearings into items. And if we get some time, I'll show you some gears as well quickly. So I've got this assembly here, fairly simple gearbox that I've created. So if you just imagine these are two gears over here, and we want to add some bearings where these gears attach now to the case of the gearbox itself. What we've got as well inside of the design workspace is we've got in the power transmission panel, we've got a bearing design accelerator. So if I select bearing over here, again, sorry, it's gone on the other screen, let me bring it across. We've got the ability to set or add in bearings based on the existing geometry that we have inside of our model space. So if I wanted to select a cylindrical face and add this one into the shaft that I've got here already, I can choose that. I can then choose a start plane, again, very similar to the bolted connection. We're selecting a start plane to start from. I'm just going to choose this edge on the outside. You can then start to see we've given a preview as to the size and dimension essentially of the bearing itself. We've got the ability to come in and set a from and to value in here as well. And we've got a few other presets that we can decide from there. But as soon as we're happy with that preset, in this case, it's required two inputs. It required the cylindrical reference and the start plane. I can then come in here and update my list. And this will go through the content center again and find anything with a relevant internal diameter, and then find which ones of those will match the criteria I've given here. So I could come in and fill all of this information in if I wanted to, and then it would come and give me a list of items that would fit inside here. As soon as I select any one of those, it will then start to give me previews of each of those bearings. So I could come in and choose any one of those. I could come in and choose exactly its exact positioning inside of the hole itself. Otherwise, if it just changes back to 0, right, offset now, it should just be on a 0 offset. So somewhere there. Yeah, I can come and choose different types of bearings as well. So if I want an angular contact ball bearing, deep groove ball bearing, I can choose again between this entire list of standard content center parts and be able to pick from those, and we'll then filter those down inside of my list over here. And once I'm happy with that selection, I can then essentially just choose to hit OK. It'll then tell me that this is now going to be created as a sub-assembly. I can hit OK on there, and it will then place that bearing down. All that's now required is for me to adjust the size of the casing for this particular assembly. So if I went back into the encasing file, I could then adjust the size of the hole and ensure that that then fits in correctly for that. But all it is it's a case of selecting the internal diameter of the bearing itself based on the existing geometry, and then you can come in and select bearings that will fit in well with that. If I move this around, you can see that we've got a bit of a bit of movement in there. If I rotate this around, you can see the bearing from the back as well. So a very simple process to be able to do that as well. The other thing we've got the ability to do is to start creating gears as well inside of Inventor using the Design Accelerator. So if I use the spur gear Design Accelerator here, again, follows a very similar process where we want to select a first component now and a second component, and start to build up some of the design restrictions essentially that we want to add in. So for our first component, I'm going to say that I want to use this cylindrical face, and that's where it will pick up the center point from. We then want to select a start plane again. So plane at which we want to start the gear from. I'm just going to select the outer edge essentially of that cylinder, if it will let me. There we go, cool. I want to flip that around because it's going in the opposite direction to what I want. So I can flip the direction of this, and then I can choose how many teeth I want for this. At the moment, 38 fits in fine. Obviously, it just depends on the ratio that you're wanting from the driving gear to the driven gear. But essentially, for the sake of keeping these two as a similar size, I'm just going to adjust the number of teeth based on that. I can then say for component 2, I want to come in and select the cylindrical face again. So I'm going to select this one, cylindrical face, and I'm going to select a start plane. What you'll notice is it's automatically, although this one seems to have lined up correctly, so I'm not going to even select a starting plane for that. And it's automatically picked up the ratio between the two based on the size of the two cylinders that I've used. If I wanted to come in and adjust that, I could come in here and say, okay, maybe I want this to be 50 teeth to 20. And then I can start to play around with that from there. Obviously, that would then require moving the center points and all of that, but that's obviously down to the way you design the item. So if I drop this back down to 37, we've got the ratio that matches the existing gears that I've placed in there, or the representations of the gear rather. We can also choose a face width. If we wanted to make this a little bit wider, we could make that 20 mil wide. Otherwise, we could drop that down to 15 or 8. And you can see how the preview gives us a nice example of what the final product will actually start to look like. Once we're happy with the setup of the gears themselves, we can just hit OK. It'll tell us now that it's going to create a sub-assembly and the two gears, spur gear 1 and 2. If I hit OK, it'll tell me that the center distance in the assembly is slightly different to what has been calculated. I'll just accept that for the sake of this and just hit accept. And it will now have created those. I'm guessing it's broken the relationship between those two cylinders, but that's okay. If I just bring this down a bit quickly, more or less in line there. You can see it's now given us those two gears. If I turn off the visibility of the two that I had modeled in, so if I just right click and toggle off its visibility and right click on the first one and toggle its visibility off, you can see how it's come in and added those two gears in for us. If I expand the spur gears option, you can see it's giving me the two individual parts, the two individual bodies to be able to create this from. So you can see using the design accelerators, we can take existing assemblies and be able to very quickly use the content center parts to be able to build this up. So rather than going in and finding the content center parts and trying to filter them down inside of content center, we've got the ability to use these. Inventor will do all of the calculations for us. And all we need to do is just hit the OK. We could always save the templates, especially for the bolted connections, and be able to reuse that data and just be able to accelerate the design process to be able to go from initial concept into fabrication and manufacturing essentially of our products. Those are just some of them. There are a few others, and I'd implore you to have a look at a few of the other ones. They are very handy to use. So yeah, thank you very much for your time. I hope that's been beneficial to you. If you'd like to see more of this, more of the design accelerators, more of any of the other features inside of Inventor, please feel free to drop us a message either inside of Zoom or on YouTube once we publish this, once we post this up. But other than that, thank you very much for your time today. I hope you've been able to get quite a bit out of this. And yes, look forward to seeing you guys again next time. Thank you.